Hello guys, in this video we are going to discuss about the tricks for Newton's laws of motion. So this is the part 1 of the series of videos for NEET and JEE. By watching this video you can solve for acceleration of any system in seconds. So again, welcome to IB360. So with the help of this first short trick, you can find the acceleration of any system in seconds. So you can find the acceleration of these systems within a matter of seconds. So let's start learning this short trick. So we know that by Newton's second law, the acceleration can be written as the net force divided by the net mass. So over here we can modify this formula and we can write that acceleration will be equal to the total pulling force minus the total resisting force divided by the total mass. So let us see the first example, how with the help of this simple formula we can find the acceleration of this system in seconds. So over here you can see there are two masses, one of mass 3 kg, another of mass 2 kg, which are connected to each other with the help of this string, and this string also passes through this pulley. So we need to find the acceleration of the 3 kg object and the acceleration of the 2 kg object. So over here the acceleration of the 3 kg object and the acceleration of the 2 kg object will be essentially the same because they are connected by the same string. Okay, so that means the acceleration of the 3 kg object will be equal to the acceleration of the 2 kg object. Why? Because they are connected by the same string. So over here you can see that since the 3 kg mass is greater than the 2 kg mass, the acceleration of the 3 kg mass will be downward, right? And suppose the acceleration of the 3 kg mass be a downward. Okay, and over here as the 3 kg block is actually moving downward, the 2 kg block will move upward, right? So that means the acceleration of the 2 kg block will be upward and the value of the acceleration will be same as the 3 kg block. That is your A. Now we can find the acceleration A in seconds with the help of our previous formula. What was that previous formula? Acceleration will be total pulling force minus the total resisting force divided by the total mass. Now over here see that the 3 kg block is actually exerting a force of 3g downward, right? And the 2 kg block is actually exerting a force of 2g downward. So over here see that the 3 kg block is actually trying to pull the 2 kg block upward by a force of 3g, right? So that means the net pulling force will be equal to your 3g. Okay, now over here see that the 2 kg block is actually giving a force of 2g and trying to resist that motion or go down. So that means the resisting force will be equal to your 2g. Okay, so a short trick to remember is that all the blocks that are going down will provide us the pulling force. Over here 3 kg block is actually going downwards, right? So that means the net pulling force will be the force provided by the 3 kg block, which will be equal to your 3g. And all the blocks that are going upward will provide us the resisting force. The 2 kg block is actually going upward, so that means the resisting force will be equal to your 2g. So that means the acceleration will be equal to your the net pulling force, that is your 3g, minus the net resisting force, that is your 2g, divided by the total mass. What is the total mass? 3 kg plus 2 kg, that means your 5 kg. So that means the acceleration will be equal to your g by 5. So that means the block of mass 3 kg will move downward with an acceleration of g by 5 and the block of mass 2 kg will move upward with an acceleration of g by 5. Now proceeding on to the second example, we'll see how with the help of this simple formula we can find the acceleration of this particular system within seconds. So over here in this example we have three masses, one of mass 4 kg, one of mass 3 kg and one of mass 2 kg. So over here you can see that the 3 kg mass and the 4 kg mass is connected by a single string. So that means the acceleration of the 3 kg block will be equal to the acceleration of the 4 kg block. And over here you can see that the 3 kg block and the 2 kg block is also connected by a single string, right? So that means this string which actually passes through the pulley. So that means acceleration of the 3 kg block will be equal to the acceleration of the 2 kg block. So that means on combining both these sentences I can say that the acceleration of the 3 kg block will be equal to the 4 kg block will be equal to the 2 kg block. Why? Because they are individually connected by one single string. So over here you can see that the combined mass of 3 kg and 4 kg is much greater than the 2 kg mass. So that means the 3 kg mass will move downward, and suppose the acceleration of the 3 kg mass be a. Similarly the 4 kg mass will also move downward and the acceleration of the 4 kg mass will be also a. Since the 3 kg mass and the 4 kg mass is moving downward, the 2 kg mass will move upward, right? So that means the acceleration of the 2 kg mass will be upward and the value of that acceleration will be A. So over here we know that all the blocks that are going downward will provide us the pulling force. Over here 3 kg block and the 4 kg block are actually going downward, right? So that means the pulling force will be provided by the 3 kg block and the 4 kg block. So that means the pulling force will be the force provided by the 3 kg block, that is your 3g, plus the force provided by the 4 kg block, that is your 4g, right? So that means the net pulling force will be equal to your 7g. And we know that all the blocks that are moving upward will provide us the resisting force. Over here the 2 kg block is actually moving upward, right? So that means the net resisting force will be the force provided by the 2 kg block. So that means this will be your 2g. So that means the net pulling force is your 7g and the net resisting force is your 2g. And we know that acceleration is equal to your nothing but the total pulling force, that is your 7g, minus the total resisting force, that is your minus 2g, divided by the total mass. Now what is the total mass? 4 kg plus 3 kg plus 2 kg. So that means equal to your 9 kg. So that means the net acceleration will be equal to your 5g divided by 9. So that means the acceleration of the 4 kg block will be downward 5g by 9, acceleration of the 3 kg block will be downward 5g by 9, and the acceleration of the 2 kg block will be upward 5g by 9. Now proceeding on to example number 3, we can see that how with the help of this simple formula we can solve this complex system in seconds. So over here in this system there are 4 bodies, one of mass 5 kg, one of mass 4 kg, one of mass 3 kg, and the last one of mass 2 kg. So over here you can see that the mass 2 kg and the 3 kg are connected by a single string. So that means the acceleration of the 2 kg block will be equal to the acceleration of the 3 kg block. And over here you can see that the 3 kg block and the 4 kg block are connected by this single string, right? So that means the acceleration of the 3 kg block will be equal to the acceleration of the 4 kg block. And the 4 kg block and the 5 kg block are connected by a single string, right? So that means the acceleration of the 4 kg block will be equal to the acceleration of the 5 kg block. So in conclusion I can say that the acceleration of the 2 kg block will be equal to the 3 kg block, will be equal to the 4 kg block, will be equal to the 5 kg block. So over here you can see that the combined masses over here is much greater compared to this side. So that means the 3 kg block will move downward, 4 kg block will move downward, 5 kg block will move downward, and 2 kg block will move upward. Now suppose the acceleration of the 3 kg block be A, acceleration of the 4 kg block will be also A, 5 kg block will be also A, and for the 2 kg block the acceleration will be A upwards. So over here we know that all the bodies that are going down will provide us the pulling force. So over here the 3 kg block is going downward, the 4 kg block is going downward, and the 5 kg block is going downward. So the pulling force will be the force exerted by the 3 kg block, that is your 3g, plus the force exerted by the 4 kg block, that is your 4g, plus the force exerted by the 5 kg block, that is your 5g. So in conclusion the net pulling force becomes equal to your 12g. And we know that all the blocks that are moving upward will provide us the resisting force. So that means the resisting force will be provided by the 2 kg block. So that means the 2 kg block will provide the resisting force 2g. So that means the resisting force will be 2g and the pulling force will be 12g. So the acceleration will be the total pulling force, that is your 12g, minus the total resisting force, that is your 2g, divided by the total mass. Now what is the total mass? 5 kg plus 4 kg plus 3 kg plus 2 kg, right, which will be equal to 14 kg. So that means from here acceleration comes out to be 10g by 14, which on simplifying becomes 5g divided by 7. So that means the acceleration of the 3 kg block will be downward and its value will be 5g by 7. The 4 kg block will move downward with an acceleration of 5g by 7. Similarly 5 kg block will move downward with an acceleration of 5g by 7, while the 2 kg block will move upward with an acceleration of 5g by 7. So proceeding on to the next example, that is your example number 4, we will see that how with the help of a simple formula we can find the acceleration of this complex system in seconds. So over here in this example we have 4 blocks. Over here you can see that the block of mass 1 kg is connected to the block of mass 2 kg by a single string. So that's why the acceleration of the block of 1 kg will be equal to the acceleration of the block of 2 kg. Similarly the block of 2 kg is connected to the block of 3 kg by a single string which passes over the pulley, right? So that's why the acceleration of the 2 kg will be equal to the acceleration of the 3 kg block, and the 3 kg block is connected to the 4 kg block by a single string. So that's why the acceleration acceleration of the 3 kg block will be equal to the acceleration of the 4 kg block. So in conclusion, the acceleration of the 1 kg block will be equal to the 2 kg block, will be equal to the 3 kg block, will be equal to the 4 kg block. Over here you can see that this side is heavier, right? So that means there is a 4 kg block and a 3 kg block, whereas this side is lighter. Why? Because there is a 1 kg block and a 2 kg block. So that's why what will happen, the 3 kg block and the 4 kg block will move downward, and the 1 kg block and 2 kg block will move upward. So now suppose the acceleration of the 3 kg block will be a downward, the acceleration of the 4 kg block will be also a downward. Since the 2 kg block is moving upward, its acceleration will be a upward, and the acceleration of the 1 kg block will be a upward, right? Now what will be the total pulling force? All the bodies that are moving downward will provide us the total pulling force. All the bodies that are going downward will provide us the pulling force, right? The 3 kg block and the 4 kg block is moving downward, right? So that means the net pulling force will be equal to the force provided by the 3 kg block, that is your 3g, plus the force provided by the 4 kg block, that is your 4g. So that means the net pulling force will be your 7g. Okay, and the net resisting force will be provided by the blocks that are moving upward, right? The 2 kg block and the 1 kg block is moving upward, right? So that means the net resisting force will be the force provided by the 2 kg block, that is your 2g, plus the force provided by the 1 kg block, that is your 1g. In conclusion, the total resisting force will be our 3g. So from here we can find acceleration. Acceleration will be total pulling force, that is your 7g, minus total resisting force, that is your minus 3g, divided by the total mass. Now over here the total mass will be 4 plus 3 plus 2 plus 1, which will be equal to our 13. So from here we get that the acceleration will be our 4g divided by 13. So that means we can say that the acceleration of the 4 kg block will be downward 4g by 13, 3 kg block will be downward 4g by 13, 2 kg block will be upward 4g by 13, and 1 kg block will be upward by 4g by 13.